I must first inform you that in this video I have to narrate the video because the audio did not get through, as I had a microphone plugged into the camera, which I assumed the camera would power the mic, but it didn't. I'll have to narrate over the audioless video. Okay, in this video I will be showing my electronics workshop, and I will also show a Betamax machine. This will be a two-part video. This is my Global Specialities breadboard that I got in late 2004. That is, it was during Christmas time of 2004. It was an expensive breadboard, and I got it at Fry's Electronics in Arizona. It's a very nice breadboard, and all the wires and all the markings that I put on it I did myself with a marker for the marking red and black. Over here we have two breadboards, very special, from an estate sale, the analog exerciser and the digital exerciser. This is the analog exerciser from the National Institute of Technology. Bring it closer so you can have more light on it. It has different controls. Well, first of all, it has a dual 12-volt supply. Okay, it has sine wave, sawtooth wave, and square wave. It has different frequencies you can choose from. Adjustment for the frequency. Offset, I do not know what offset is. And level, which controls how strong the signal comes out. It's a very nice device. Now I'll show the digital exerciser. I'm sorry, I don't sound, it's just kind of monotonous, but the digital exerciser is very neat. Has a 5-volt supply only. Has a pulsers on it. Yeah, very nice. I'll be showing about the pulsers. The pulsers are used to send out signals for digital circuits. The way it's positioned is there's a 1 and there's a 0. There's two little breadboards which correspond to each switch. And there's one that side, and then that side there's a 1 and then there's a 0 respectively. Push it down and it's 1, let it go and it's 0 for the left side. 1, 0. And for the other side, 0, 1. See? 1, 0. For that side, 1, 0, 1, 0. And for the other side is 0, 1, 0, 1. Has some LEDs built into it, as well as some switches which I think send out voltage through those breadboard parts there. If you saw the video called My First Counter, it was built on there, and I used the pulser. It would count whenever fed with a 0 and not with a 1. Okay, right there you can see a boat that goes to a 131 Project Lab kit. Okay, now here's a power supply that I built. This power supply I have completed around 2 o'clock this morning. I started it on Wednesday, building the first circuit, which was just the LM317 circuit. Then on Thursday morning I did the next circuit, the other one. And then I worked more. There's a friend of mine who has a shop that they do signs at, and he helped me drill a hole because he had the right tools to drill a hole for the meter, and some other larger drill bits that we didn't have helped out with the drilling of the holes here, so I could complete this power supply project. It's very nice. It has 5 volts out of these, and out of these it's adjustable about 1.2 to it's at 1.2 to about 30 volts. One part uses an LM317 for the first one. The second one uses an TL783C, I think, which is supposed to go up to 125 volts. Of course, it's not fed with enough voltage to do that, and it only goes to about 30 volts like the LM317 does. This power supply was inspired because I had a Heathkit power supply, model IP2718. I had got it maybe in 2004 or so, and I had had it for a while, but sometime 2007 or so I lost it or something. I couldn't find it. Okay, now this is the best. The switch is put on like upside down. I didn't notice that until I tested it, but I had a hard time getting the switch on there because of the little nut was so close to the meter. Now the meter is not accurate. Unfortunately, it's not very accurate. I have it set for 5, but you go beyond that and it will get more and more inaccurate. It's close, but it's not very accurate, unfortunately. But it's a nice vintage meter. The switch here is A and B, because you have it on the top, it's for A, and that's B. So you have it on the top, it will show the voltage on A, put on the bottom, it shows the voltage on B. So you can see what voltage you're coming out of each adjustable power supply. I know it's in monotone. That there is for ground. That actually hooks up to the third prong on the 3-prong plug, which I believe goes into the earth itself. So I can use that for the ground, or for a genuine ground. For instance, radio circuits that need an actual ground connection. I don't want to be trying to find some cold water pipe to hook it up to, so I did that. Separate from the quote grounds on the, and then the negatives. It's separate from that on the power supply. I'm hoping you're following what I'm saying. I was more descriptive and less monotone when I was actually making the video. I was talking about all this stuff, only to find the video to lack audio and have to narrate it like I am doing right now. There's a nice vintage lamp you can see. Got that from a rummage sale, by the way. Oh yeah, down there you can see. Okay, right now I'm showing the power supply again. Oh, I'm talking about how I had the Heathkit one and how it got lost and how I could never, ever find it again, no matter how hard I looked. Okay, organizers. I got these organizers from an estate sale of organizers of electronic components. Aside from this one I already had. And that one's also from the estate sale. And those two. And then the mechanical pencil I got from another estate sale. That I got from an estate sale. It's full of transistors and diodes. I'll show you. With these meters, I already had these meters. And this camera, the tape transport on the camera doesn't work very well. It's messed up, doesn't play the tape properly. That's why I don't use it anymore for the videos, but it does have a good camera on it still. Okay, I'll show you the inside of this box. I'm sure you're bored with me right now because of my monotone speaking, but whatever. Showing my box here. It's full of transistors and diodes. I know it's kind of dark on the lighting. There's diodes in there, transistors, NPN transistors in there, and some PNPs in there, and there's some more transistors and bags down here, as you can see right there. Some transistors, power transistors. It's very nice. And yes, these boxes, a lot of these have these 7.4 chips, like the 7400, for example, like a Paulette right there. And also I have a lot of the 40XX chips, like the 4011, stuff like that. I'm very glad about that. Also have an LM383 audio amplifier, just one. Have some other audio amplifier chips in there. I also am very happy to have ownership of a ZN414 and also 2 TDA 7000s, which I can use to build radio circuits. Which I'll probably try to do sometime. You have all kinds of different stuff. We also got capacitors that I have sorted out into those boxes there. That particular organizer had a lot of empty boxes. And we got capacitors out of that case. And here's a bunch of capacitors, smaller values right there. And I want to show you something for capacitors. Here. After, I'll show you some more capacitors here. All electrolytics. I've got some smaller ones too, some ceramics and milers as well. But here is the capacitor meter that I found at the same estate sale. I was not expecting to find such a contraption to actually test capacitors, capacitance with. But I managed to find that. I'm very happy, and I want to show it to you. I want to show it operate. Turn it on. 0. Here's a capacitor, 100 microfarad, 50 volt by Ritchie. And let's see if it's good, and let's see its capacitance. stick it on the things, and 127 microfarad. Now you can see it's like pulsing. It sends a pulse into the capacitor, and I think it measures how long it takes to charge and discharge the cap, and from there is able to make a calculation as to the capacitance of the capacitor. Yeah, I just burped. Excuse me. Or chicken soup. It was not chicken soup, but if my friend Evan sees this video, he will understand exactly what I'm talking about. It's an inside joke, basically. This is a new 470 microfarad capacitor, not old. Let's see what it says. 464, 463, 464. It's not far off from 470. You can see it's taking longer to calculate because it's a higher value capacitor. It takes longer to charge or discharge, I guess, the capacitor. Gives you a clue to how the capacitor meter actually calculates the capacitance. And here we have transistors, and here on the left we have NPN, on the right we have PNP. These were already in my collection. Here we have also the classic old CK722 transistor that is blurry on the camera. Turn that off. It has a nanofarads and microfarads, but not picofarads. By the way, that box that I'm putting it on top of is full of more chips of the 7.4 and 4.0 type series. 4.0, not O, but I just say O. Everyone says O. Okay. This breadboard, and I got those breadboards, but I haven't seen breadboards yet. Here is a powered project board that I made. Okay, there was this thing that we went to called Project Lab. I heard about it when I was in the 6th grade in 2004. Unfortunately, it was canceled later on the same year, I think, when I was in the 7th grade in 2004. Unfortunately, the person who was doing it, his eyesight was not getting very good, and he had to cancel Project Lab. But what Project Lab was a very, very awesome thing where electronic enthusiasts would go meet up on Friday nights in this church building, and they had all kinds of taken apart stuff. All kinds of stuff. People could take stuff apart, they could build projects out of things, and add components and build projects and stuff there too. What I did is me and the person who ran Project Lab became good friends, and we worked together to bend the metal that went onto this board here. Most of the stuff I built, but the metal I had to get help on that. The breadboards, what inspired me to do it was the breadboards had the slots on them where you could connect them together. And then I had this pegboard thing, which on the other side would have a board that you would draw on with chalk. It was just a toy, but it made a great board. And so I put the breadboards on, and have the wiring on one side for the power supply. The transformer is under the metal part, as well as a relay. The relay is to prevent it having that fade out from the capacitors when you turn it off, because I liked it to turn off like just right away. But anyway, this was built all in 2004, mostly by me, aside from the metal working, which I got help on at Project Lab.